Hi there, this is Penelope, and this is an excerpt from the MG5004 2016 Trimester 2 exam. We're looking at questions 3 and 4. Question 3 is on complex numbers. The first one, it's much easier to do in polar form, so if we convert each of those brackets to polar form, first one becomes root 5 angle 63,435, and that's still to the power of 2. And multiply that by 5 angle negative 336.81 to the power of 3. That's got to be divided by 5 angle 53.13 to the power of 4 times root 5 angle negative 26.565 to the power of 3. Okay, using de Moivre's theorem and then using the way that we multiply complex numbers once it's in polar form, then the top line becomes 625 angle 16.44, and the bottom line, I've left it like this because then it's going to be easier to cancel, times 5 root 5 angle 132.825. Okay, we can cancel out the 625s and we're left with 1 over 5 root 5 angle negative 116.385. Now you could leave it like that, or you could change it to the decimal version of it, and you could put the angle around the other way. Either way, it doesn't really matter. And then I've run out of space, but a tiny wee sketch. It'll be in the third quadrant like that. Pretty tiny, but at the angle of 243 all the way around. For part B, you need to just treat these as ordinary fractions. So it would be 5 plus J3 minus 5 minus J3 over common denominator, which of course is just going to give us a real number on the bottom, and on the top it gives us J6. If we convert that into rectangular, we get 0 plus, okay, that's 6 over 34, 3 over 17. And if we put that into polar, it's 0.1765 angle 90 degrees. You weren't asked to draw it, so don't draw it, just leave it like that. The last part of that question, it's going to use the double angle formulas. So first up, get rid of the brackets. Now it's a case of sine A plus B, so you can expand that to become sine A Thank you. Sorry about that. That's the fire alarm. Never mind. So cos J pi by 4 plus cos B, cos A sine B. And that would be fine, but we've got these J's in here, and that's where you remember that cos Jx is equal to cosh x, and sine Jx is equal to J sine sinh x. So that's just something to remember. Now it means that we can replace the sine J with J sinh, and the sinh and the cosh we can look up on our calculators. So that becomes 1 over root 2 times 1.3246, looking it up on the calculator, plus 1 over root 2 times J times 0.8687. And just use your calculator to work that out. 0.9366 plus j times 0.6142 and show it on a diagram. Both of those are in positive first quadrant. So the imaginary part would be the 0.6142 and the x part would be 0.9366. Question 4 is on logarithms. And the first question is pretty easy. Using the base change formula, don't use your calculator. Well, how do I know if you use your calculator? Just undoing that says that it's that you've got, stop that, that log 2 of 32, so that becomes that, and then what that's saying is what power of 2 is 32, and the answer is 5. The next one, solving log equations. Remember, you've got to clear this first, so it would be natural log x squared plus 1 equals 3.9 over 3, which is 1.3. Take each side to the power of e, so you get x squared plus 1 equals e to the 1.3. X squared equals e to the 1.3 minus 1, and x, don't know what that is, then x squared, x equals plus or minus the square root of e to the 1.3 minus 1. 3 marks. The next one is fairly straightforward, using logs to solve an equation. All you've got to remember there is that you're given the information that says that I over IS equals 300. So putting the question, I equals IS times e to the 40v minus 1. So we can divide both sides by IS, but I over IS is 300. Add 1. And then taking the natural log of each side and dividing by 40. Will give us v. And if we use the calculator to find that, we'll find that v is equal to 143 millivolts. The last part of question 4 is asking you to solve something which kind of looks a bit like proving something, but it's not. It's just solving. So we need to write out what the left-hand side is, write out what the right-hand side is, rearrange it, then see if we've got some quadratic that we can solve or whatever, and go from there. Now, by definition, cosh 2x is a half of the average of e to the 2x plus e to the negative 2x times 3. And the right hand side, we've got 3 and then we've got sinh, which is going to be a half times the difference of these. Now collecting them all onto one side, we get e to the 2x plus 2e to the negative 2x minus 3 equals 0. It doesn't really look much like a quadratic, but if we multiply every term by e to the negative 2x, it might help. Then we've got 1 plus 2 e to the negative 2x minus 3 e to the negative 2x. If we make a replacement now and we say let z equal e to the negative 2x, then we've got Oops, I've left out this one. That should have a squared in it there. Then we've got 2z squared minus 3z plus 1 equals 0. That's a quadratic that will factorise as 2z minus 1 and z minus 1. So z equals a half, or z equals 1. Now remember, z was actually e to the negative 2x, so that means that e to the negative 2x equals a half or 1, and undoing that gives us that x equals negative a half natural log of a half, or that x equals 0. And if you needed to, you could put that as a number.